kites. Guess what? A kite looks like a kite. Yeah, I'm not kidding. It's not just a clever name. K-I-T-E-S. What's the definition? And what are the properties? Properties. While we're answering those questions, you want to ask yourself, where does this puppy fit into the hierarchy? All right, what do you think's true? Madeline?
I think that the ET is congruent to IT.
Say it again, I'm sorry.
ET is congruent to IT.
You are correct.
And EK is congruent to IK.
Awesome. How about a definition for me then? That's enough to give us a definition.
If a shape has, if a quadrilateral has.
Wait, hold on. If a quadrilateral is a kite, comma, then
It has two congruent.
it has two pairs
Of congruent sides.
of congruent sides? Isn't that a parallelogram?
Yeah.
Is a kite a parallelogram?
No.
No. Okay. So how does the kite differ than the parallelogram?
I'd say it's adjacent, but it's not because then EK and ET are adjacent, but they're not the same. So I don't really know.
You're on the right track though. So we have to get the verbiage together so that we can say that those top two are congruent and those bottom two are congruent. But we can't use top two and bottom two because kite could be turned. Okay, so the way we're going to say that is two pairs of, actually I'm going to erase a little bit here. Sorry. We're going to use the word distinct. Two distinct pairs of adjacent congruent sides. Distinct pairs means there's two pairs and each pair is separate from the other so that we don't have any overlap. Because like she said, if we just use the word adjacent, then KI would be congruent to KE, but KI would also be congruent to IT, and that doesn't work. Okay, because then we end up with a rhombus, and we don't want a rhombus. Well done. Okay, what else is true about that kite then? I think I asked the question already, but Madeline, is it a parallelogram?
No.
No. Okay. Dev?
ES is equal to SI.
ES is equal to SI, that is correct. Good. What else? Sebastian?
Are the diagonal like perpendicular?
Are you asking me or telling me?
Telling you.
Yeah, they are. And the reason I'm not writing anything down yet is because I want to get all this information because some of it might combine into properties that we can summarize with just one instead of like 6 different. Okay, Deb, you gave me ES congruent to SI. What about KS and ST? Are they congruent?
No.
No. Because if they were congruent, then it would be a parallelogram, and we know, because Madeline told us, that it's not a parallelogram. Is there any relationship between KS and ST, in your humble opinion, Deb?
Maybe.
That's a safe answer.
Maybe KS is like half of ST.
Could be, but doesn't have to be. There is no relationship. Okay. Now the question is, how do we say all that? No? Let me give you some another term here. We're going to call two of those points ends. Okay, so the ends of a kite are the vertices between the congruent sides. So which two vertices are our ends? Mm-hmm.
K and T.
Good, K and T. So K and T are the ends. Now we want to explain all that stuff that Deb gave us in the middle, and now you can use the term ends. With a parallelogram, we could say, well, the diagonals bisect each other. But they don't in this case. Only one diagonal bisects the other diagonal. How do you explain that? Which diagonal is the knife? Which diagonal is the bread?
KT bisects EI.
That's true, but we want a general way to phrase that so that we're not dependent on kites that are only labeled the exact way we have it labeled. Go ahead.
Vertical.
You know why that won't work, right? Yeah, okay. Emily?
The longer diagonal.
Doesn't have to be, that's the weird thing about it. Paul?
The diagonal going from the ends bisects.
The diagonal connecting the ends is the, not only is it a bisector, it's a perpendicular bisector. Bisector, I don't know why I put an E there, of the other diagonal. Other diagonal, which you can clearly read there. Good. Okay, let's talk about some angles then. What about the vertex angles? What do you notice? Are they bisected? Yeah. So EKT is congruent to IKT. For those of you who are visual, I'm asking about these angles. What's the relationship between those two angles? What's that? Yeah, they are. What about ETS and STI? They're congruent. Okay, good. So it appears that the diagonals bisect the vertex angle. What about KIE and EIT? That angle and that angle? No. Only two of the vertices, vertex angles, are bisected. Which ones? The ends, yeah. The ends angles are bisected. I hope there's nothing else because I'm running out of room. There are a couple other things, like for instance, notice that EIT is an isosceles triangle, KIE is an isosceles triangle. All four of the smaller triangles are right triangles. The top two are congruent to each other. The bottom two are congruent to each other. So these are congruent. These are congruent. That's isosceles. That's isosceles. This bigger one on that half is congruent to that other one. There's a whole bunch of congruent triangles in there. Not a big deal. Okay. And again, we'll come back to the idea of where does this fit in the hierarchy. After we talk about trapezoids, we're going to figure out how to put this and trapezoids into that hierarchy. Okay, we good on kites? All right, let's move on then to trapezoids. Morgan, what do you got for me? What do you think?
Are T, R, and P parallel?
They are. Hold on. Okay. Good. Anything else? Morgan? Correct, there is nothing else. It's really boring. That's it. So we need a definition, Morgan. What is that thing?
If a shape
It's quadrilateral, so we'll go there. Is
a trapezoid,
a trapezoid.
then it has one pair of parallel sides.
I'm going to get fancy here and throw in exactly one pair of parallel sides. Because we don't want to accidentally make the mistake of saying, well, maybe those other two sides could be parallel. That's going to open up a whole new can of worms. Now, as far as properties go, there's the only interesting thing about it, it's not even that interesting. The only thing about a trapezoid that you should notice is that angle T and angle P are supplementary, and angle R and angle A are supplementary. But you already knew that because what kind of angles are those? Consecutive interior, right. So that's not a new property, so pretty much there are no properties. It's a boring figure. However, we could do something interesting and introduce something called a median, which I don't really like when we use the same word for different things. But if I take the midpoints of these things, oh, by the way, the parallel sides are called bases. Bases here and there. Want to guess what these things are called? Legs. If I take the midpoint of the bases, sorry, if I take the midpoint of the legs and connect them, that's called a median. It's a median of a trapezoid, not to be confused with the median of a triangle. Or not to be confused with the statistical median.
Is the base always the sides that's parallel?
Yes. So median is the segment connecting the midpoints, I don't know why I changed to blue, of the legs of a trapezoid. Two properties about the median. Number one, well, you tell me, what would one of them appear to be? Becca?
It's parallel to the bases.
Good. Parallel to the bases. And number two? Anyone want to guess? I wouldn't expect you to know this. Its length is the average of the two bases. The length is the average of the two bases. Okay. Take the two bases, add them up, divide by 2, that'll give you the length of the median. Quarter after? Bell rings? Okay, good. I'm doing okay. We good so far? Not a real exciting shape. However, we can tweak this a little bit and get a new shape. And that would be an isosceles trapezoid. What do you think an isosceles trapezoid is? I don't want to draw one because it'll give it away. Michael.
And the ones are congruent.
Beautiful. So what would our definition be, Michael?
If quadrilateral is an isosceles trapezoid, then it has one pair of parallel sides, another pair of congruent sides.
Yeah, we could just go with it's a trapezoid that has congruent legs.
All right.
Okay? Good. This one has a couple more interesting properties. It seems like I'm going a little fast, but I want to get to the hierarchy before we get done here. Aside from the legs being congruent, which is part of the definition, and the stuff that's true about trapezoids, the other thing to notice is that the base angles are equal. So this angle is equal to this angle, and that angle is equal to that angle. What do you notice about the diagonals?
The bisect diagonals.
Nope. Good guess, though.
And congruent to each other.
They are congruent to each other. Do they bisect each other?
Yes.
No. You had a 50-50 chance. Yeah, the only thing about the diagonals is that they're congruent to each other. That's only true in isosceles trapezoid, not in a plain old trapezoid. Okay, so base angles. Number 1, base angles are congruent. Number 2, diagonals are congruent.
What's the definition?
Definition is a trapezoid with congruent legs. Okie doke. Beautiful.
Wait, what's the definition?
Trapezoid with congruent legs.
Wait, so the angles are only congruent in isosceles trapezoid?
You got it.
just trapezoid?
Yep. There's pretty much nothing interesting about a trapezoid. So all these things that you think might be true apply to a isosceles trapezoid. Okay, so we had quad, parallelogram, square down here. I don't remember how we did it yesterday. Is this rectangle or rhombus?
Rectangle.
This is rectangle over here. This is rhombus. Okay, where do trapezoids, isosceles trapezoids, and kites fit in? Shep,
Stemming off of quadrilateral.
you want to go left or right?
Oh wait, do they all go in the same place?
No.
Okay, well then.
They could. I don't know.
To the left,
You want to go to the left?
yeah.
What goes over here?
Trapezoid.
Okay.
And then to the right will be kite.
Not bad.
And then the isosceles trapezoid coming off of trapezoid.
Beautiful. Well done. Isos trap. Zoid. Zoid. All right, there you go. There's your completed hierarchy. We'll do a little bit of work with that. In fact, we'll do a lot of bit of work of that tomorrow. I've got a ton of worksheets that'll help you, not tomorrow, Monday, help you practice that kind of stuff. I would suggest at some point between now and Friday, you need to start, if you haven't already, looking at that final exam review packet
Are you gonna put the answers
of,
Final exam review.
yes, I will.
up this weekend?
We good?
Why and what?
Awesome.
Yeah.